If you've tried to build a computer recently, you've hit a brick wall. A standard 64 GB kit of DDR5 memory, which used to be a relatively affordable component, will now run you somewhere around $900. It is completely natural to assume this is simple corporate price gouging, and if you look at the history of the memory industry, that suspicion is entirely justified. Between 1998 and 2002, federal investigators ripped open the dynamic random access memory market. They uncovered rampant, systemic, illegal price fixing, levying hundreds of millions of dollars in fines against the top manufacturers. Corporate executives were caught coordinating hardware prices during secret meetings in Taiwanese hotel rooms. When the federal investigations concluded, the companies involved had to publicly admit their guilt. For decades, the hardware supply chain operated under these conditions. It was never a flawless meritocracy. It was a tightly controlled arena where a few dominant players manipulated output to keep their profit margins high. Today, that control is even tighter. Following years of brutal price wars and bankruptcies, only 3 companies remain standing: Samsung, SK Hynix, and Micron. Together, they dictate 95% of the global market. The standard tactic for any cartel is simple: restrict the supply of your primary product to artificially inflate the cost for consumers. But right now, these 3 manufacturers are doing something very different. They are permanently shutting down their own highly profitable consumer sub-brands and actively dismantling the supply lines that PC builders rely on. A corporate oligopoly does not destroy its own primary revenue stream for a short-term margin bump. They only tear down their own infrastructure when an overwhelming external force breaks the entire system. That force is the massive, sudden expansion of enterprise artificial intelligence. Tech giants are buying up infrastructure at an aggressive scale, completely bypassing the consumer hardware market. These AI servers don't use standard DDR5 RAM. They require a highly specialized, resource-intensive architecture called high bandwidth memory, or HBM. This diagram illustrates exactly how much physical silicon is required to manufacture these chips. Because of lower fabrication yields and complex packaging, producing a single gigabyte of high bandwidth memory consumes exactly 3 times the physical wafer space as standard consumer RAM. When a massive data center places an order for AI servers, the factory has to frantically reallocate its floor space. Every gigabyte of enterprise memory they agree to build physically erases 3 gigabytes of consumer memory from the production line. The entire global tech industry is limited by these physical disks of silicon. There is a hard cap on how many can be produced in a single month. The $900 price tag is not a manufactured shortage. Consumer RAM has simply been demoted to a highly inconvenient, low-margin byproduct of the AI gold rush. The obvious response is to ask why these multi-billion-dollar companies don't just build another factory to meet the demand. The answer lies at the atomic level. Scaling modern memory production requires engineering on a scale so microscopic, the physics actively fight back. This cross-section shows a modern DRAM capacitor. To store data at current densities, these structures are built with extreme 50-to-1 vertical aspect ratios. At this scale, the silicon threatens to mechanically collapse under its own physical weight. To prevent these atomic trenches from collapsing, manufacturers have to use extreme ultraviolet lithography. These lithography machines are some of the most complex devices ever constructed. A single unit requires multiple cargo planes to ship, costs hundreds of millions of dollars, and demands highly specialized cleanroom environments just to operate. Even if the capacitors survive, high bandwidth memory requires stacking incredibly thin silicon dies on top of each other using microscopic copper pillars. One slight error in temperature or alignment warps the material and ruins the entire stack. The market isn't starved for supply because of a boardroom conspiracy. It is blocked by the unforgiving limits of material science. This graph plots hardware progression. While processor speeds climb exponentially, memory bandwidth remains flat. Engineers call this the memory wall. AI processors are incredibly fast, but starve for data, sitting idle because memory physically cannot scale fast enough to feed them. The absurd cost of consumer hardware is the direct collateral damage of an industry crashing headfirst into this bottleneck. Samsung, SK Hynix, and Micron are locked in a $1 trillion war of attrition, pouring every resource into bending the laws of physics just to keep the AI sector functioning. The computing industry was built around the personal terminal, hardware designed to be accessible, scalable, and sold directly to the user. That era is over. The standard PC builder is now an afterthought in a supply chain dedicated entirely to industrial-scale infrastructure. The limits of atomic engineering dictate everything from the size of a massive data center down to the price of components on the shelf. The corporate manipulation of the late 90s is gone. Instead, we are left looking at the absolute ceiling of our own technological capability.